question 9. More vectors. The equation of a straight line L is given by that, 3, 1, 1 plus t, 1 minus 1, 2. The point P on L is given by t equals 1. Calculate the acute angle between OP and L. It's one of those questions that you kind of feel maybe we do need a little diagram just to work out, just to get into our head what is actually going on here. So this is the line L, and the vector that represents the direction of this line is that vector there. The vector 1, minus 1 or 2. This just represents a point on L, that's all. And the point P on L is given by t equals 1. So there's actually a point P that lies on this line. And the point P, well, OP is 3, 1, 1 plus 1 times 1 minus 1, 2. That's what the vector OP is defined as being, because that's what this means. This is how to get from the origin to that point. So this is 4, 0, 3. So that's our position P. Right. Calculate the acute angle between OP and L. So hang on, that's it. There's O. That vector is the vector OP, and that vector is 4, 0, 3. The line, the direction of the line is given by the vector 1, minus 1, 2. So this is what we need to do. We need to find the angle between this vector and this vector here. And that's just our scalar product thing, isn't it? So the vector, you've got that alternative form of it where we can write cos theta is A dot B divided by the magnitude of A times the magnitude of B. So we can go straight into doing that. And we don't need to worry too much about these. This is the angle that we're looking for. Now we will find the angle between OP and that line. So we're going to find that angle that's in there. But it doesn't matter, if that comes out as being acute, then brilliant, we found the acute angle between OP and the line. If it comes out as being obtuse, we take it away from 180 and we're okay anyway. Cos theta is, so that is 403 dotted with 1, minus 1, 2 over 4 squared plus 0 squared plus 3 squared times 1 squared plus minus 1 squared plus 2 squared, which is 4 plus 0 plus 6 divided by, now that's quite nice on the bottom, isn't it? Because 4 squared plus 3 squared, that's a Pythagorean triple, that's going to give us 25, so that's root 25, which is 5. And this is going to be what we've got in there. Oh, root 6, I think. So that's 10 over 5 root 6, which is 2 over root 6. I know, I should have come to that. Anyway, okay, so we're going to do inverse cosine of that, see what it gives us. The fact that that's positive is suggesting to me that we've got the right angle straight away, because that's going to give us an acute angle. And have anybody done it? I think I got 35.3 to 3 significant figures. Well, of course, we're going to give our answer to 3 significant figures unless it tells us otherwise. They accepted a radians answer if you wanted to give it in radians. Cool. Right. Part 2. Find the position vector of the point Q on L such that OQ is perpendicular to L. Well, this is quite a nice idea. If we kind of think again of our little diagram that we had. Here's the origin. We've now got some point somewhere along here. Remember that equation just generates. I meant to write the letter Q there. That equation generates these points in here. And as the value of t changes, it just generates all the different points. And all that they have in common is that they all lie somewhere along that straight line. we're looking for the particular one that when we find it, it ends up being that that vector is perpendicular to that vector. Now remember that that direction vector is the vector 1, minus 1, 2. We know that. So we need to come up with a vector that represents the position of Q. Well, there's quite an easy way of doing this. You take your equation and you just combine what you've got in this equation into one vector. So the value of t that we're looking for is such that OQ is, and we're going to write this as being 3 plus 1t, 1 minus 1t, and 1 plus 2t as the components. So 3 plus t, 1 minus t, and 1 plus 2t as the components. So that's it. That's how we're going to represent the position vector of Q. It's just another way of writing the equation of the straight line. So that vector is perpendicular to that vector, so its dot product is 0. So 3 plus t, 1 minus t, 1 plus 2t, dotted with 1 minus 1, 2, is going to give us an answer of 0. If we multiply this through, then we've got 3 plus t minus 1 minus t plus 2 lots of 1 plus 2t gives us 0. What have we got there? 3 minus 1 is 2, plus 2 is 4, and we've got t plus another t is 2t plus another 4t. I think that's right. So if we rearrange that, 6t equals minus 4, so t is minus 2/3. Sorry, not that very well, minus 2/3. And the question did say find the position vector of the point Q. So we need to sub that value of t back into our equation for OQ. There it was, so 3, take away 2/3. Let's write it out. 1 minus minus 2/3. And 1 plus 2 times 2/3, so 1 minus 4/3. Gives us Q as being the vector 11 over 3. No, that's wrong. 7 over 3. Good save. 6 over 3. Hang on, that can't be right. 5 over 3. And minus 1/3. There we are. You could have taken the third out as a factor and left it with a... Great. What did part 3 say? Find the length of OQ. Okay, so we just need to find the length of this vector here. It's just a bit of throwing numbers at a calculator, isn't it? The length of OQ well, you know, you can, at this point, you can use your calculator and just type everything in and do 7 over 3 squared plus 5 over 3 squared plus minus 1 over 3 squared and just do it like that. And you're going to get, what's this, 49 plus 25 is 74 plus another one, 75 over 49 over 9, where the 49 came from, which gives us 75 is 5 root 3 over 3. So you get your answer like that. I was hesitating because I probably wouldn't do that. You know what I would do, don't you? I would take the third out as a factor first and say it's a third of the square root of 7 squared plus 5 squared plus 1 squared, and do it like that. It gives us root 75 over 3 anyway, doesn't it? Which we then cancel Grand. Everybody happy? And that's maths.